Hi viewers, today we are going to learn about the capacitor and the thing is capacitance. What is meant by capacitance? It is the capability of the material which stores the electric charge within it. So electric charge Q. Okay. So the symbol of capacitor is like this: two parallel plates, two terminals, and we call it as capacitor. And the units for capacitor is farads. F. We denoted with F. So let us see here. This capacitor is connected to a circuit. What happened? Connected to a circuit and a voltage is connected to the capacitor. So the capacitor is connected to a circuit. It should be like this. See here, this is the voltage plus terminal minus terminal. This is the capacitor and a current I is flowing through it. Okay. So now what happens? Now definitely the charge should be stored on the two plates of the capacitor. Okay. Here the charge is what? Negative charge or electronics, whatever it is. Electrons, sorry. So now this voltage is connected to the circuit. What happens? Current will flow through it. Now the charge stored in the capacitor Q. The charge stored in the capacitor Q is directly proportional to voltage applied across the circuit. Is it right? Q is directly proportional to V. So to remove this proportionality constant, we are going to add a constant. So we are considering the capacitance C. We are considering the C as a capacitance. Okay. So Q is equals to CV. Q is equals to CV. From this, what we are going to do? We are going to derive the voltage equation. From this voltage equation is V is equals to Q by C. Is it right? So from this, it is the voltage equation. Now we are go for the current equation. Current equation. Coming to this current equation, let us consider a small current is flowing through the circuit. Okay. So the current equation. Let us see here the rate of charge with respect to time due to the rate of voltage with respect to time. Now already we know that Q is directly proportional to V. So here also these two are proportional to each other. So to remove this proportionality constant, what we are going to do? We are just make the like how we make the capacitance constant here. Here also we are going to take the capacitance constant. Then what happened? We know that integral of dq by dt is equals to I. Sorry sir, not integral. dq by dt equal to I. So the dq by dt equal to I. So we can do it here. I is equals to C into dv by dt. So this is the current equation. Okay, this is the current equation. Now let's go. I is equals to C into dv by dt. This is the current equation. This is the current equation and this is the voltage equation. Now coming to the power equation. So power equation. Power equation. P is equals to V into I. So we all know this P is equals to V into I. P is equals to V into I. So we know that what is the equation for I? Current equation. Substitute this current equation here. P is equals to V into C into dV by dt. Is it right? Then what happened? We know that P is equals to CV into dV by dt. So it is the power equation. We call it as a power equation. Is it right? Now see, it is the voltage equation, current equation and power equation. Now energy stored in it. This is the power equation. P is equals to VA. So P is equals to C into V into dV by dt. Let's see energy stored in the capacitor. energy stored in the capacitor. So we know that energy is the work done. So let us take a small rate of work. dW is directly proportional to dq. Is it right? So to remove this proportionality constant here, already the voltage is applied to the circuit. So we are considering voltage as a constant. Then we can write dW is equals to V into dq. Is it right? So to get the work, we know that what is the value of V? So we know that V is equals to Q by C. So I am going to write this like this. So to get the work here, we are going to integrate this dW is equals to integral of V into dq from 0 to q. Apply integral on both sides. Apply integral on both sides. Okay. Now what happened will become work done W is equals to, we know that V is equals to, from this voltage equation, V is equals to QC. So integral 0 to Q, V is equals to Q by C into dq. Q by C equal to dq. Now from this equation, substitute here, then what happens? So Q is equals to CV. Substitute that Q is equals to CV here. Then what happens? I am writing here. I am writing here. Okay. So W is equals to, so first to write half, apply by applying the integration, you can write it as half Q square by C, 0 to Q. Then it will become half Q square by, Q square by C. Okay. By applying the integral, it will become Q square. So we know that half Q square is what? If you want Q, send this V, C this side. Then what happens? It square becomes C square, V square by C. C gets cancelled. Then we get done is equals to half CV square. Is it clear? Is it clear? So this is the work done or energy stored in the capacitor. Capacitive reactance. Capacitive reactance XC. XC. So we know that XC is inversely proportional to omega. What is this capacitor reactance XC, which is inversely proportional to 1 by omega? And to remove this proportionality constant, we are writing XC is equals to C by 1 by omega into C. And we know that omega is equals to 2 pi F. So XC is equals to 1 by 2 pi FC. Here this is all about the capacitive reactance of the capacitor. Okay, capacitive reactance X equal to 1 by 2 pi Fc, and we have to see the overview of this capacitor. So capacitor is a capability of the material which stores the electrical charge Q within it, and we know the symbol of this capacitor and units farads circuit when it is connected to the circuit. Q is directly proportional to V. So we have derived the voltage equation, current equation, and power equation and energy stored in the capacitor and the capacitive reactance.